Okay, so you've built a RAG app. The demo looks awesome, everyone's impressed. But what does it actually take to go from that cool prototype to a powerhouse system that can handle the real world? Well, that's exactly the journey we're going to take today.
Look, the first thing we gotta get straight is this. Production RAG isn't just about picking a fancy model. It's a full-on engineering challenge. The large language model is just the last piece of the puzzle. Its answers are only ever as good as the information you feed it, which means that whole data pipeline beforehand, that's what really makes or breaks your success.
All right, and just so we're all on the same page, what even is RAG, right? It's basically the technique that lets us give a large language model its own private, custom knowledge base. Instead of just relying on its general training data, which can be old, we retrieve specific, up-to-the-minute facts from our own documents to ground its answers. This is how you build an AI that actually knows your stuff.
So here's what we're gonna cover. We'll start by talking about that gap between a prototype and a real production system. Then, we'll lay out the core framework you need. After that, we dive into the fun stuff, the secret sauce of tuning, how to supercharge performance, and finally, how to scale it all without breaking the bank.
All right, let's kick things off with that first big hurdle. Why is it that the prototype that looks so great on your machine just isn't ready for prime time?
You know, this is a feeling every developer has had. Your demo just crushes it on a few PDFs, and you're thinking, I'm like 90% of the way there. But let me tell you, that last 10%, whew, that's where the real engineering work begins.
And this slide just nails the difference, right? On one side, you've got your prototype. It's running locally, maybe handling a handful of documents, and you're just kind of tweaking things by hand. But on the other side, that's production. We're talking scalable, serving tons of users with super low latency, and, this is key, where quality is measured with cold, hard data, not just a gut feeling.
So how do we get from one side to the other? Well, you've got to build for scale right from day one using a really solid architectural framework.
You can really think of the whole system as two main pipelines. First, you've got the indexing pipeline. This is all the offline prep work, right? Ingesting your docs, chopping them up into chunks, creating embeddings, and loading it all into your vector database. Then, you have the online part, the retrieval and generation pipeline. This is what happens in real time when a user asks a question. It finds the right info and spits out an answer.
Okay, now we're getting to the secret sauce. This is probably the most critical part of the whole process, using a scientific, data-driven way to actually measure and improve the quality of your answers.
And if you remember one thing from this whole explainer, let it be this quote: "The LLM is only as good as the context you retrieve for it." Seriously, if you feed it the perfect little snippets of info, even a so-so model can give you a brilliant answer. But if you feed it garbage, well, even the most powerful model in the world is going to give you garbage back. So, how do you actually improve that retrieval process without just guessing? It's all about being methodical. You change one and only one variable at a time. Could be chunk size, could be the embedding model, whatever. Then you run your tests. And here's the cool part. You use a powerful LLM like GPT-4 as an unbiased judge to score the quality. Find the winner, lock it in, and move on to the next variable. It's literally the scientific method, but for RAG.
Check this out, a perfect example of that, in action. The team tested how many chunks of text they should retrieve, and you can see it right there on the chart. The quality score, as judged by GPT-4, just keeps climbing as they add more context, and it peaks right at 9 chunks. That's what data-driven tuning looks like. No guesswork, just results.
And they did the exact same thing to compare different models. The results are kind of surprising. Yeah, GPT-4 Turbo came out on top, but look at the open source Mixtral model. It was super competitive, even beating an older version of GPT-4. It just goes to show you can't assume anything. You have to test, measure, and let the data tell you what's best.
Okay, so you've nailed the basics. Now it's time to bring in the heavy hitters. Some advanced techniques to really squeeze out every last drop of performance and tackle those really tough accuracy issues. First up, hybrid search. Now, vector search is amazing for understanding the meaning of a query, right? The semantics. But what if you need to find something super specific, like a product number or an exact phrase? That's where keyword search still shines. Hybrid search just combines them both. You get the best of both worlds, the semantic understanding and that pinpoint lexical precision. But an even bigger game changer is something called re-ranking. You see, the problem is that your initial search might find a bunch of relevant stuff, but the absolute best piece of context might be buried at number 5 or 6. Re-ranking fixes this. First, you grab a wide net of potential documents, maybe 30 or 50.
Then, you use a second, smaller, specialized model whose only job is to reorder that list and push the absolute best result right to the top.
And wow, does it make a difference. Just look at this. Adding a re-ranker boosted their quality score from 3.61 all the way up to 3.95. That is a massive jump, putting the system right up there with the best of the best.
All right, so your system is super accurate now? Awesome. But can it handle the real world? We're talking about scaling up, which means managing costs and, just as importantly, making sure the system keeps getting better over time.
And that brings us to, well, the billion-dollar question, literally. We saw that the best models like GPT-4 Turbo are also the most expensive. So how on earth do you deliver that amazing state-of-the-art quality without completely breaking the bank?
The answer is actually pretty clever. It's called LLM routing. You build a simple, lightweight classifier that looks at a user's question first. For the easy stuff, the vast majority of questions, like 95% of them, you send it to a cheaper, super efficient open source model like Mixtral. But for that small 5% of really complex questions that need serious brainpower, that's when you call in the big guns, GPT-4.
This is how you get the best of both worlds, right? For most of your traffic, you're using a model that's something like 25 times more cost-effective. You're saving your most powerful and most expensive tool for only the moments where it's absolutely necessary.
And last but not least, a production system can't just be done. It needs to evolve. You need what's called a data flywheel. This is a continuous loop where you're constantly monitoring for failures, getting user feedback, and digging in to find the root cause. And you know what? A lot of the time, the problem isn't the model or the code, it's an error or a gap in your original documents. Fixing your data at the source is the single most powerful thing you can do for long-term quality. Okay, so let's tie this all together. What are the big takeaways? First, building a production RAG system is a serious engineering discipline. Second, you have to use a quantitative, one-factor-at-a-time process to tune it. 3, advanced tricks like re-ranking can give you a huge quality boost. 4, you need smart routing to manage costs as you scale. And finally, and this is the most important one, the quality of your source data is everything. It is your biggest lever for success.
And that really brings us full circle. You can have the most amazing models, the most optimized code, the whole shebang, but at the end of the day, it all comes back to your data. So, your RAG system is built, it's tuned, it's ready to go. But let me ask you this, is your data ready for it?